In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths Mechanics paper 4.2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts if you need to. If you're looking for a different question from this paper or a different paper entirely, check out the description below. You should be able to find a playlist there or have a look around on my channel. Okay, let's get into the maths. In question one, we're told about a crate being pushed along a horizontal surface. So let me draw the rough idea of this. We have a crate here and it's being pushed with a force of 25 newtons. But then they tell us that that force is actually inclined above the horizontal. What that means, inclined, it means it's going upwards. Someone is maybe standing here pushing up on it. We tend to draw that simply as a force going up. I don't care that the force actually was over here pushing on it. It's identical to someone with a rope pulling up on it. It makes no difference to us. We tend to draw our force like that. They then tell us that it moves a distance of 12 meters over 8 seconds. And that's actually all we need to answer part A, because part A simply asks us to find the constant speed of the crate. They told us the crate moves at a constant speed after this. So the constant speed of the crate is speed is equals to distance divided by time. So it's 12 divided by 8, which is 1.5, and that's meters per second. So that's the answer, part A. There's only 1 mark for that, so you shouldn't be too surprised that it was quite quick. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, moving on to part B. This one seems very easy. It's quite easy anyway, but it seems very easy. It talks about work, find the work done. So you do want to try and remember your formula for work. Work is equals to distance times force, or I guess that's usually wrote as force times displacement, or F times S. So how much distance did it move and how much force worked on it? Now I would forgive, although I wouldn't give them the mark, I'd forgive a lot of students to think, well, this is easy, 25 times 12. It did in fact move 12, they told you that, but the force acting on it was not 25. The 25 newtons was acting up and off to the side. It didn't move it, this 12 meters. This force, only some of this force moved it horizontally, those 12 meters. So what they wanted us to do was to break this force up into the force that moved it horizontal, and so a lot of the force was wasted. It was just going up in the air, as it were. So they want us to break this force up. Sorry, I left out the 20 degrees here. They told us this was. Yeah, so this is relatively straightforward. You should do this 10 times in a mechanics exam. We want to break a force up. We think of this as a triangle. The hypotenuse is 25. So I just want to find the height here for this height. I want to find this length down here for this force. So that's just trigonometry. It's a sine of 20 is equal to the opposite. So this length here divided by the hypotenuse. Rearrange that and we get 25 sine 20 is this number. That's the wasted force. I'm not interested in that one. This one is just the opposite, 25 cosine 20. The same, cosine 20 is equal to the adjacent, this length down here, divided by 25. Okay, this is the force we're interested in. This is the force we should have used for this formula. So W is equal to 25 cosine 20, and all that's multiplied by 12. Go ahead and put that in on a calculator, and we get to 3 significant figures. We get 281.907,
But to three significant figures, it's 282. And remember your units, it's joules. Although, I'm not sure I should say this, but I'm fairly sure you don't lose marks for forgetting your units in mechanics. You definitely don't in the other maths papers. You know what? Put your units in. Make sure to get that extra mark. Okay, for part C, they ask us to find the power at which the 25 Newton force is working. Again, we need to remember our formulas here. Power is equal to force times velocity. So what was the velocity? The velocity was over here. The force, again, same one we just found out here. So this power is 25 cosine 20, this time multiplied by 1.5. Again, there's only one mark for this. That's because a lot of the work was already done. Put this in on your calculator, and it's three significant figures. You get, I can't read my own writing. I can see it now. 35.2. And what's the unit for watts? For power. It is a watts. So that's it for question 1. If you have any follow-up questions, anything I did wrong, or you just want to ask me anything, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.